Hi, again Javier Orozco. Welcome to the sub-module Architectural Materials within the Blended Learning course of Essence, which is, as you know, an Erasmus Plus project. And the module on which this sub-module is included is the physical transition, where we are considering how to make this future sustainable city. The details: we should analyze materials through the different families and architectural subsystem, because we can provide solutions which are specific for the subsystem through materials. Then analyze the impact of traditional materials, learn different lessons from them into building new materials which are sustainable, and provide the basis for materials selection. So let's go into the detail. First, remember the architectural subsystems are from the foundation to structure, envelope, partitions or walls, facilities or functional approach, and providing elements to the functional work, and the different stuff, different furnishings that we include in the building. All these subsystems have especially different constraints which are to be integrated also with the elements which are more at the design level, which are provided by the architectural concept of the buildings. Lines and colors are interactive for providing, like is the case here in the City of Arts and Sciences, with a nice environment which is shaping how we see and feel within the building. Light and shadow is not only a nice approach, but also a functional one, because we need lights for working, and we should introduce the value of the work we are performing at these buildings by selecting rightly the shapes and elements in the building. The overall volume is then meeting the space requirements and provide the solution to all these in architecture, which is form. The different elements are providing constraints from the structure. We have to withstand external action, transmit loads, and provide long-term support over 50 years. All these are integrated with the envelope, because this is what's isolating us from the exterior part, sheltering us from the environment, and also controlling the transfer of thermal, light, and humidity, water, and so on, constraints to the buildings, and housing utilities, distributing the services and evacuating waste, and defining spaces. So all the materials families that we are going to introduce will be better in providing this load transmission. This is the sheltering, the functional distribution, and creating a space that meets the architectural constraints. Again, the functions are here. These are the constraints: transmit vertical and horizontal loads, dynamic, like in earthworks buildings, long-term services, are met typically with these materials: steel or cast iron, different metals which are cheap and readily available, timber, wood, or even brick or stone. All these materials have in common that they can provide good average solution to these constraints. In the case of the envelope, we should control transfer of air, heat, water, radiation, provide acoustic separation, and the typical materials are glass, aluminum, or different polymers, which should be insulating, integrating fibers like in hybrid materials, or more modern materials which are made either naturally or artificially. But again, the hybrid solution is a very good future approach which is being implemented now, because it decouples the problem of meeting their requirements. Then we should see how the walling, the partitioning of the space should be considered. These are the constraints: delineate the spaces, provide climatic zones, and separating the different elements, even including finished services, health, and other safety considerations. Again, wood, polymers, resin, fabric, tiles, and so on. And the last point is how to provide the services, the climate conditioning is the typical one, but also lighting, humidity, and water. And again, here the number of materials is greater. As you can see, it's being changed from one to another, but what they have in common is the basis. So any analysis should be taken into consideration these families of materials, which are the best solutions for meeting the constraints. Then, let's go into the actual materials and let's learn lessons from the past. Typically, in this very ancient setup of Machu Picchu, they needed first a hearth where they could put fire and they could therefore have a climate control for their individual houses. Here they needed to support the fire through ceramics. Then they had to put a roof on top of them. The structural approach that was done through carpentry, that is closed either through weaving or in the walls through the use of stones. Obviously, all these materials were natural, were close to them because they could use no other element, and they were reusable. So these are the basic lessons that are implemented, like in using leaves, branches, furs, or different natural skins from animals, using a stone, clay, adobe, lime mortar, including cinders for humidity control, and are substituted nowadays by concrete, steel, bricks, aluminium, plaster. All these new materials have in common that are readily available, are very cheap, they don't need a lot of labor, but are in most cases damaging to the environment or need a lot of energy or cannot be reused. So the lessons again are to be able to provide the same functional and economic solutions, but including the consideration of these ancient materials. Typically, the most important are the reuse, the renewability of the material, of the resource, and of course, the close availability to where we are using the materials. The new materials, very fancy as you might see, is this MIT building, although it's not very sustainable, are providing both polymers, metals, composites. All in all, they are integrating all the different functions together through a matrix and some functional elements. Again, this has come into important failures when the modular approach are really not well designed because they are not modular at all, first, or are using more material in a less efficient way. Again, the use of mass production or strange shapes for the buildings are really non-sustainable, although they might be new, but nothing to be considered in our design. And the last, of course, is these new high-performance materials or fibers like carbon and fiberglass, which are no good for the sustainable building because they are very expensive energy-wise and not reusable. So again, these are failures to be considered in these new redesigns. Next point, let's go building by building. This huge building has basically glass and either aluminum or steel. This is not reusable. The curved shape and the specific spacing is a very important limitation, and the use of layers to avoid UV radiation is a very important limitation for the reuse of the glass as it is. Isolation through materials like gypsum or fiber composite board is nice for isolation, but again not reusable or even damaging to the environment. Think of asbestos, for example, in the past. Again, using aluminium as a skin is very nice and fancy, as we can see here, but very expensive in energy. And providing a sheltering layer on the back of whatever material we put on the outside of the building, again, is expensive, although we need to provide solutions. So the best is to couple all of them together in the exterior wall. Introducing materials such as silica aerogels in this apartment building is really intelligent, because once the life is finished for the building, we can reuse these sub-elements, or we can even take the whole lot and use it elsewhere. It provides a good solution for lining, so this is a very nice integration and development of a hybrid material. Be careful with the bridges, the thermal bridges on the building, but all in all it's a good solution, which provides an aesthetic approach to the building. Then architects are going forward into sustainability. The Pritzker architecture price, if you see in their website the evolution of the different prices, is becoming more and more aware of natural sustainable materials into the solution provided by these priced architects. Again, for selecting the materials, we need a database that's including data tables, references on how this information was obtained for being able to assess them, include processing of the materials, and be able to detect which suppliers could be available. All these databases are assembled into universities, families, class members, and attributes in the CES EduPack 2015. That's the software you will be using in the different examples for the course, and you should be aware on how to use all this solution, all the information that is provided, and the software in the different databases, which provide specific solutions once you check and go through the classes and members, and allow for identifying criteria or material performance that you were not perhaps aware before using the material. All in all, with this information, we are able to assemble a material selection. In this link, you will be able to assess how to go through the software, and you should produce solutions for the expected exercises that you will find on the website. Again, this is the final summary on architectural materials and their selection. Thank you very much.